it rubs the lotion on its skin, or it gets the hose again. G'day everybody and welcome back. I want to talk about brakes. I want to talk about brake fluid. I want to talk about master cylinders. I want to talk about how the systems work and why they're such a pain in the ass to bleed. So right here in front of us we have a couple of different things. We'll start this by talking about brake fluid. Now there's different types. This is a .3 and this is a .4. It's actually a super .4. It's got more borate in it. But essentially brake fluid, I mean, to go back to the horse and cart days, things used to putt around and you could get away with using a block of wood against the rim or a bit of leather, a strap of leather or something to slow the vehicle down. Then as cars started to get faster and heavier, then of course we needed to be able to apply more force, because whatever force you need to apply in energy to accelerate a mass to a certain speed, you need to apply the same energy to bring it to a stop in the same distance of time. And that is frictional energy, and that energy usually dissipates out through your brake rotors into the atmosphere or your brake drums. And of course some of that heat makes its way back into the brake fluid. So at a certain point in time, in a timeline, the Department of Transport, the US Department of Transport, laid down a set of standards for brake fluid composition. And the idea was that manufacturers had something that they could produce a product to, a set of standards, and they knew that that particular fluid, when put into a vehicle, was going to be safe for the public out on the roads, and it wasn't going to fail. So what's all the .2, .3, .4, .5, .5.1, what's all that about? Essentially, it's to do with the boiling point. Now, originally the .2 fluid, which I don't have any of, I don't know if anyone's got any anymore, was a castor oil and alcohol of some type. Blend. There's two different boiling points with brake fluid. There's what they call the dry boiling point, and then there's the wet boiling point. The dry boiling point is talking about a system that's been charged with brand new fluid, and it has very little moisture in the fluid, because brake fluid, the glycol ether blends of brake fluids that we have now, what they term as hygroscopic. So that means that they will actually absorb moisture out of the atmosphere. And that water, of course, has a much lower boiling point than the fluid itself, so it can flash to steam, and of course that means that it's compressible, which means that it's no good in your system. And not only that, it promotes corrosion as well. So the dry boiling point for .2 was 190 degrees Celsius, which is 374 degrees Fahrenheit if you're watching in black and white. Then there's a wet boiling point, and the wet boiling point is how that fluid performs with a certain percentage of water absorbed into it. And I think it's 3.7% from memory. If I'm wrong, I'll research that, and if I'm wrong, I'll pop it at the bottom of the screen. But the wet boiling point obviously is going to be a lot lower, because it's going to, the fluid's going to boil off at a much lower temperature. And for .2, that was 140 degrees Celsius, which is 284 degrees Fahrenheit. Then so that was a castor oil alcohol-based blend. Then along came the modern brake fluids, like this Nulon product, which is a .3. And the .3s are a glycol ether mix. And they have a dry boiling point of 205 degrees Celsius, which is 401 degrees Fahrenheit. The wet boiling point is still 140, the same as it was for .2, but the dry boiling point is a lot higher. So then along came .4. Now .4, is particularly good when you've got a lot of heat being generated. from things like ABS systems or high performance braking situations. And dot 4 has a dry boiling point of 255 degrees Celsius and a wet boiling point of 155 degrees Celsius. And then there is another, so dot 4 actually has borate in it and esters. So it's got the glycol and ether, plus it's also got the borate ester. And dot 5.1 has as well. So when you'll often hear people talk about compatibility issues. Dot 3, dot 4, dot 5.1, they're all fine. You can put them, don't mix them together, but you can replace one with the other. It's the dot 5s are silicon based. Dot 5 is a silicon based product, and it won't mix with the glycol products or the glycol ester products. So you can't put a 5.1 silicon into a system that has contained or is designed to contain the dot 3, dot 4 or dot 5.1. Being silicon, there is also some mineral oil ones on the market, and the mineral oil and the silicon ones what is referred to where the glycol esters are hygroscopic. The silicon and mineral oil based ones are hydrophobic, so they actually won't absorb water, and they stay nice and non-compressible for the better part of its life, and they run higher temperatures as well. So that's a bit about fluids, and there is a compatibility chart that I've seen kicking around, so I'll dig that up somewhere and I'll put it up on the screen too, about just to show you that what you can mix and match. But let's get down to the nut cutting. I've got here in front of me 2 master cylinders, and these are typical motorcycle type master cylinders. This is a Nissan one off a Yamaha. Actually, it's off the XS 1100. So this one has a cast-in reservoir. It's all it's part of the body of the master cylinder. This is a master cylinder off a Ducati, and it is a remote master cylinder. So it has a reservoir with a hose going into here. This particular this particular master cylinder failed. It started leaking out of the end of the shaft not long after I got the bike, actually. And I thought, all right, well I'll just put a kit in it. So I tried to buy a kit, but during the 90s, my Ducati is a 96 model. During the 90s, there was a period of time where Brembo were frightened to death of litigation, and were worried that if they sold the public rebuild kits for master cylinders and the public got it wrong, they could end up in an accident and Brembo could be liable for actually making those kits available. So they took them off the market. You can't buy rebuild kits for some Brembo master cylinders, and this is one of them. So once I found that out, I went and ordered another master cylinder. But the problem that I've got with it is that this is the original one off the bike. So I want to rebuild this because original. The one that's on there is off a newer model Ducati. It's even a different colour. I mean, I could paint it, but I want to keep that bike original. And I thought I might be able to use the one that's on the Ducati currently on basket case, because Brembo. So it's in my interest to get this going, and I intend to do that, because I found once I got the replacement master cylinder, pulled this one off the bike, put the other master cylinder on, and it's been on there for a couple of years now. But I discovered when I did that the reason it was leaking was because at some point a previous owner had been playing with it. This is the main piston seal assembly, and there should be a rod, about 6mm diameter rod, that comes out like this, fits down into there, and there should be a rod between it and the lever, and you adjust any free play or anything there, and that rod's missing. So instead of it being able to push in a linear motion, it's actually pushing like a bell crank, like it's twisting, and it was pushing this sideways, and that's why it was leaking. So all I need to do is make a new pin for that, and I can reuse it. So that's exactly what I'm going to do. Right, getting back to my point about all this. So what I've got is, as I said, I've got two different types of master cylinders here, which are common to motorcycles, and we can have a look at how they function. Now, this on the Ducati Brembo master cylinder, it has a single seal, a single lip seal that fits down into the master cylinder. It's of course preceded in there by a spring. Gone and popped it in there now, haven't I? Now I've got to try and get it out. Right. Okay, so it's actually preceded in there by a spring. That spring sits in like so, and then that feeds into the main chamber. And then it has a seal on the outside that goes something like that, and it's retained by a circlip. And that is meant to prevent the fluid leaking past here and out into the atmosphere, and also prevent air or water getting in and creating havoc with our brake fluid. They are common insofar as they both operate the same. And what I might do is go over to the whiteboard and we'll have a look at how they work. Listen, one of my subscribers, and I forget who it was, I'll have a look and put their name on the page, on the screen, suggested that I go and get myself a pair of Motion Pro, because I was struggling to pull apart one of these master cylinders one day on a video, and he pointed it out to me that Motion Pro make master cylinder circlip pliers, which are brilliant for getting down into that cavity there to get that jolly circlip out. And lo and behold, I looked them up online, there they were, and I ordered a set, and they are brilliant. So whoever you were, thank you for that, because I've used them a couple of times since, and they are good. All right, so before we trottle off to the whiteboard and have a look, as we know, we've got some type of seal arrangement in a chamber, and there's two seals, so there'll be one to stop the fluid and moisture and air on the outside where it's exposed to the elements, and there's also the operating seal inside the master cylinder. The Nissan master cylinder, this particular one, has two cup seals. This is the Brembo one, which only has one. It has a second cup seal in the Nissan that moves with the piston. It's a dynamic seal as well that provides the barrier between the outside elements and inside the master cylinder, whereas the Brembo has this O-ring arrangement. Just a couple of different approaches to the same thing. This is my really, really crude diagram for a master cylinder. So we have a chamber with a piston that operates within the chamber, and we have the reservoir sitting above it. Now, whether it's cast as part of the unit or whether it's something that is remote mounted, it matters not. It has a reservoir. The job of the reservoir is to retain fluid in there that it can replenish the system with as required, because as your brake pads wear, the piston's going to be moving in to compensate for that wear, and that means that there's more volume of oil behind the piston, so the reservoir will drop. It's also designed for redundancy purposes. If you do get a little bit of a leak here or down at your caliper or in your hose, provided it's not catastrophic failure, there should be enough fluid in there for you to notice that it's starting to drop, and that means that you need to go and find that leak and deal with it. So yes, the fluid sits inside the reservoir, but it also sits down into the chamber, into the main master cylinder. and it floods behind. This is the seal here. Now that seal in the rest position sits right on the edge of that little vent port. Now if I shine a torch inside the master cylinder, you'll see what that vent port looks like. It's tiny. That seal sits between the replenishment port and the vent port. And so you've also got fluid down in here as well. So that spring's job is very important. That spring's job is to return that piston and that piston seal to the rest position, the start position, which is right on the lip, right on the edge of that vent port. So what happens when you grab the lever or you put your foot on the brake, the piston moves forward and it instantly moves in front of this vent port here. So when it does that, it's sealed against the bore of the master cylinder, and it starts to build pressure because it's got nowhere to go now. And the reservoir, and in fact all the area behind the seal, remains at reservoir pressure. However, anything forward of that vent port is building in pressure as you depress your foot on the lever or you grab the handlebar lever. The tighter you grab it, the more pressure you build. Now Pascal's law states that if you have a non-compressible fluid like brake fluid in a closed system and you apply a force, that the pressure in that system is distributed evenly and undiminished right through the whole system. So that means whatever pressure that you build in there is being applied to not only the lip of the seal, which actually helps it seal in the system, because you have a high pressure on this side and you have a lower pressure on the other side, so it's going to press against the wall of the master cylinder. That pressure is also being applied in all directions, undiminished, right through the hose, right through the down to the caliper, on the back of the piston. So that whole thing builds in pressure and it's even. We need a little bit more energy available to us than what we could probably apply by hand. So what they do is they improve the ratio, the hydraulic mechanical ratio of this system. While the pressure is equal and undiminished, if you can get that pressure to act on a larger surface, you will achieve higher force. So what they do is they build in either more pistons into the caliper or a larger piston into the caliper. Now on an older bike with single piston calipers, you know, they're probably about double, as just guessing off the top of my head. If you had a half inch piston here, you might have, say, a 1 inch piston on your piston. So that distance across there is larger. So the same amount of pressure is being applied to it, but because it's spread over a bigger area, it has more force. The only trade-off for that is that it will, if that's double that diameter, it will only move half as far for the same input. So if you were to move that, say, 5 millimeters, this would only move 2.5 millimeters. If that makes sense. But the thing about hydraulic braking systems is that they only have to relax and only have to be a thou or two off the rotor for them to have relieved the pressure and not drag the brake. So we have a tube running down to our piston, which is housed within a caliper and applies a clamping force to our disc rotor. Now, if that had two pistons, it would be applying an equal and undiminished force to both pistons, and if it had four, it would be doing the same. So if we had four pistons like so, we would, let's just take it off here for the purposes of demonstrations. We would then have 4 pistons with a clamping force. Now the reason we have flexible hoses is because we have a swing arm and we have forks. So we have motion and we obviously need to control that. It's better if you have a solid line, which is why in any opportunity in all cars and in some motorcycles, they'll actually run a hard line and then just have a bit of flex. at the end where they need it. Because the caliper has to be able to float often, and also the suspension has to move, so you need to compensate for that. You can't have a solid pipe. But because bloody Pascal has to go and make these laws where the pressure is applied evenly and undiminished, if your hoses are a little bit old, they can become spongy, and some of the energy that should be going into your pistons actually presses against the hose, and as the hose swell, and it absorbs energy, which makes your brakes feel really spongy and not very positive. On basket case, I've got what they refer. You'll hear a reference to stainless steel braided hoses. Essentially, what they are is they're a Teflon lined flexible hose with a steel wrap on the outside that helps to prevent any movement inside that hose. It's important that you change your brake fluid every, as per your factory recommendations. And I guess in some countries it might be more than others, I don't know. Just refer to your manual. So on top of this reservoir, because this stuff is hygroscopic, we don't want any moisture getting in, and we also don't want any atmosphere getting in, because it contains moisture that this stuff will very efficiently pull out of the atmosphere. So they have a neoprene or some form of rubberized seal on the top. And that creates a barrier between the reservoir and the outside elements. However, it's no good if it can't be at the same pressure as the reservoir, because if you had a lower pressure condition here, you could hold the fluid up and it may not come into the flooded chamber. So this needs to be equal to the reservoir, which is essentially atmospheric pressure, which means that the lid above it will have some form of vent. It'll have a hole in it, or it'll have some sort of pathway for the outside atmosphere to be able to equalise above the diaphragm, so that as the fluid is drawn down, it doesn't create a low pressure situation in here where it's holding up the oil. If you look in your manual, you'll see a recommended free play that you either have on your lever or on your pedal, and it's important that you set that, because what you don't want is a situation where you've got no air gap, and even worse, you've actually bumped that forward slightly and it can't come back to that start position. Because one of the things that will happen is that, what will happen is that the brake will drag. And the reason the brake drags is because we've got this high pressure system here that we've moved that piston forward, and we've built this high pressure. And then when the piston comes back, if it can't clear that vent hole, the pressure remains in there. So the brake drags. The minute that piston comes past that vent port, that whole system is able to equalise with the reservoir. So it relaxes, and the brake pads relax from the rotor. If the piston can't travel back, then it can't relax. So it stays dragging. The pad will drag. The brake pad will drag, and that'll generate heat. And the hotter it gets, the more it heats the fluid up, and the fluid expands and grabs the brake even tighter, to eventually you'll get to a point where the brake will actually lock up. This is also indicative of a blocked port, the vent port. If it becomes blocked, you also have that scenario where you'll end up with a locked up brake. So if you're experiencing dragging brakes, you may need to empty your system out. And I use a little piece of a very fine guitar string, an E string, lower E string, or pluck the hair out of a wire brush and poke it in that hole and give it a clean out, because it only needs a little speck of rust or poop in there and it will block. So now that we understand how a brake caliper works, we've got replenishment port here behind the seal, we've got the vent port in front of the seal, we can understand why they're a pain in the ass to bleed. My God, how hard are they to bleed? Now, a couple of tricks that you can try. You might have heard of one where people say, just cable tie the lever back onto the handlebar. The reason that you do that is because it moves the piston forward of that that vent tube. So you've got, if there's any air trapped in here, it's not going to help that. But what it will do is it'll allow this to bubble up air as it sits overnight. The air will just sort of work its way up and out, and this chamber will flood properly. Because this is the key part. This is the hard part, getting this bit right. You can put oil in the reservoir, and then tap the lever back and forward, and you'll see bubbles popping up. You only want a little bit of fluid in the bottom of the reservoir. You'll see the bubbles working their way out as the fluid sort of moves back and forward between these two. Once you get this area here full of oil, then you're a good portion of the way to getting your system bled, because if you can't get the air out of here, you're never going to get it out of anywhere else. One of the other things that you can do is use like a hypodermic syringe without the needle. Draw some fluid in out of your container, put a little bit of fluid in the bottom, and actually move the piston forward, either with the lever or with the foot pedal, and actually inject a bit of oil down into there and allow it, if the pistons move forward in front of the vent port, you can allow that oil just to sort of work its way up in there and get that happening. Once you get that bit done, then what I normally do is get a rag and just wrap it around the end of the chamber and crack the banjo fitting there. And just as you would as you're bleeding your calipers, you'd make sure it's tight, compress the lever, crack it, close the fitting, release the lever, pump it up again, crack it, close it, release, and just do that process until you start to get the oil moving, all the air out of that system. Now, one of the things I haven't gone into is rotors and calipers. I did mention the difference between a single piston caliper and multiple piston calipers, and why they do that. It's to get a greater mechanical advantage at the caliper for the input on your lever. Some systems have fixed rotors, some systems have floating rotors, some systems have fixed rotors and floating pistons. It's important to understand which your bike has. If it's a floating caliper, then when you're servicing your brakes, you need to make sure that assembly, that the caliper itself can move freely in the bracket that it's mounted with. On the pins, generally there's a couple of pins in there. But don't go smearing them with grease or anything like that. Just make sure they're clean and that they're reassembled correctly. You don't need to. Grease will do a couple of things. One, it'll attract dirt and create even more wear. And two, it can dry out and go sticky. And three, it can melt under higher temperatures and end up on your pads or your rotors or your tyres. And you could have an issue there with not being able to stop or losing traction. So don't go putting friction modifiers on a device that's designed to create friction. Some bikes have floating discs. The Ducati has riveted discs, but they're not a floating type. They're actually lock solid. If they do have thimbles on there, when you're servicing your brakes, it doesn't hurt to put a bit of brake clean on there, and you can put like a bolt and a nut through the centre of the thimble, and just with a spanner gently make sure you can get them turning and that they're all working as they should. Anyway, that's all I wanted to do, was just run through a little bit about brake fluid composition and the compatibility issues around mixing .3s and .4s and .5s, what they're all about, what the different dots mean, how a master cylinder functions, and the best way to go about getting it bled, because it can be very frustrating. One of the other ways of doing it is to actually back bleed, so come from the caliper back up. You can do that through buying proprietary type hand pump hand pump brake bleeding kits, or you can just use a hypodermic. But the reality is that if you do it from the top down and you get that master cylinder bled, that's the key. Get that master cylinder bled first, and the old cable tying it up against the grip is a good way to do that. If you're having trouble, just let it sit overnight with that and then come back and try again the next day. And it's that whole zen and the art of motorcycle maintenance too. I'm a big believer in that. If I'm not in the bloody right mood and I'm getting frustrated, the best thing you can do is walk away. Oh, that's it for me. I hope that was helpful to someone out there. Don't forget to like, subscribe and comment, and I'll catch you next time on Andy's Motorcycle Obsessions. Bye for now.